Hello friends, so today we are going to solve the this is the part 2 of part 2 of the questions from the year 2021, and in this part 2 we are going to solve total of 14 questions, and all these 14 questions are from the mains. Beside this part 2 we have to also do one last one for this 2021 question year, that will be consisting of the mains as well as advanced. So that will be the part 3 of the this particular year 2021. So the first question, it states that a short straight object of height 100 centimeter lies before the central axis of a spherical mirror whose focal length has absolute value f is equal to 40 centimeter. The image of the object produced by the mirror is of height 25 centimeter and has the same orientation of the object. One may conclude from the following information. So here we have to find out whether the image will be real or imaginary or virtual, and it will be what kind of mirror, and whether it will be same side of the mirror or the opposite of mirror. So here first of all we are going to take care of the magnification factor. The height is given as 100 centimeter, where the image height is given as 25 centimeter. So we can say that the image height of the image is less than the height of the object. Okay. And second thing, it says that the orientation is same as that object. Okay. So we are given that image orientation is same as that of object. So from the height part we can say that the image will be at least virtual. Okay. So image virtual, there are only two options, option number 2 and option number 4. But it also says that the image orientation is same as that of the object. So it means option number 4 is the correct option, which is a convex mirror. So you can say we have a convex mirror. And image is virtual. Therefore, option number 4 is the correct one. Is correct one. Next question. It states that the incident ray, reflected ray, and the outward normal are denoted by the unit vectors A, B, and C respectively. Then choose the correct relation between these vectors. So we are given three vectors A, B, and C, and A represent our incident ray, B represents our reflected ray, and C represent our outward normal. So based on this description we can draw an approximate figure. So we have an incident, that is of A, and the outward normal, that is our C, and finally we have our reflected ray, and that is our B. And we have angle of theta between the incident and the reflected with respect to the normal, that is our C. And we can assume that this is our x-axis and y-axis. So this will be I unit vector, and we have this as j unit vector. So we can divide our A vector into the corresponding I and j vector. So we can say our vector A will be equal to sine of theta plus I minus cos of theta j. Similarly, we can say that our B vector will be equal to sine of theta I plus cos of theta j, and our C vector is equal to our j unit vector. And here we have to check all the options one by one. So if we see option number 1, we states that B vector is equal to A vector plus twice of C vector, okay, which is not possible, not a correct statement, because if we do twice of C, then it won't be equal to B vector. So this is not the correct one. And fourth is also obviously not correct, because B vector is not equal to A vector minus C vector. So we are left with our second option. Second option says that twice of A vector, because this will be resulting in our, if we say twice of A will be our twice of sine theta and twice of cos theta, and plus j. It will be not equal to our B vector. So we are only option left is 3 option. So we can just try it out. We are given that A vector is our sine of theta I minus cos of theta j minus, and we have twice of, this is equal to A dot C vector, and can I
Just to confirm, you'd like to call Daniel on mobile.
sorry. And this comes as sine of theta I vector minus cos of theta j vector dot C is represented as j unit vector, and this whole is multiplied by j vector. So this gives us sine of theta minus cos of theta j, and this comes as I dot j and j dot j, and this I dot j cancels out, so we are left with only this is 2, and we get the cos of theta and multiply by, this is minus minus plus, and j unit vector. So this comes as sine of theta I unit vector plus cos of theta j unit vector. This is equal to B. So option number 3 is the correct one. 3 is correct. Next question. A point source of light S placed at a distance of 60 cm in front of a center of a plane mirror of width 50 cm hangs vertically on the wall. A man walks in front of the mirror along a line parallel to the mirror at a distance 1.2 meter from it. See in the figure. The distance between the extreme points where he can see the image of the light source in the mirror is in centimeters. So we are given this figure. We have a mirror. Let us call this as mirror as M. We have a point source S, and man is walking this way, which is parallel to the mirror, and respective height of this mirror is given 50. Distance between the mirror and man walking is given as 1.2, and similarly distance of the source is given as 60 centimeter. Now this question we can more or less solve using basic triangle. So let us draw the figure, and we are given a mirror, and in front of the mirror, let us suppose this is the center of the mirror, and we have a source S which is 60. So corresponding image will be formed also at a distance of 60. And we can just this is the path on which the man is walking, and this is our light from the source. And we are given that our this angle, let us suppose is theta, so other angle will be also theta, and let us draw a line parallel to the main axis. So here also we are going to get this angle will be also theta, this will be theta, theta on the and theta, and let us call this distance as x. Because of symmetricity, the other distance will be also over x. Therefore the total will be equal to 2x. So we find out x, and we can easily sort out for the other part also. And so here we are given that this is our 60, and this total is our 1.2 meters, and height, this height of the mirror is given as 50. Therefore the half height will be equal to 25. So this is our S. Let us call this as P, this is Q, we have R and S, T, this is our U, and let us call this as V, and this point is our I. That is our image. So if we take our triangle, and let us call this point as O. So in triangle PIO, in triangle PIO, and we can just draw the triangle here. So we have this as 60, this is about 25, we have P, I, O, and this angle is of theta. Therefore we can say that our tangent of theta will be equal to 25 divided by 60. And similarly, in triangle, the bigger one R, and we have this as in triangle R, I, and T. Okay, you can say in triangle, this triangle R, I, T. Okay. Once again, we find out tangent of theta. You can say in triangle R, I, T. So this angle is our theta. This is our R, I, T. RT we assume this is our X, and IT will be equal to 60 centimeter plus 1.2 meter. That comes as 120 centimeter plus 60 is equal to 180 centimeters. So this comes as 180. So therefore we can write that tangent of theta will be equal to X upon 180. 1, and let us call this as 2. Therefore we can say from equation 1 and 2, from equation 1 and 2 we can write 25 by 60 is equal to X upon 180, and here 18 goes by 3, and this gives us that our X is equal to 25, and the total distance between the extreme point, so we found out our X, this is our 25, so other portion will be also equal to X, that is 25, so total will be equal to, sorry, not 25, 75. This is our 75, and other part will be also 75. Okay. So we got our X 75 here, and this is also X, that is 75. So the distance between the extremes, that is our SV, distance between extremes, that is our SV, sorry, not SV but RV. RV is equal to twice multiplied by 75, and this comes as 150 centimeters. So answer is 150. Okay. So we can say that in case of this optics, the properties of triangle plays very important part. More or less you will be able to figure it out, that using the triangular property also helps in solving the question. Like in this question, we were able to sort it out. Next question. It states that the angle of deviation through a prism is minimum value. So we have to find out the condition when the angle of deviation in the prism minimum, and the figure is given to us also. So this is angle of deviation, and if we complete the figure, if we draw normal, these two normals here, this will be our angle of incidence, okay, and this will be our angle of emergence. We have two internal angles, that is our R1 and R2, and this is our angle of prism, that is our A. And we know that our for minimum deviation, or in case of this for minimum deviation, angle R1 is equal to angle R2, and angle of incidence is equal to angle of emergence. And also the line, you can say, inside the prism, a ray inside the prism is parallel to the base. Okay, you can say ray inside the prism is parallel to base of the prism. So we can say that the reflected ray inside the prism becomes parallel, so option number B is the correct one. The incident is equal to angle of emergence, option C is the correct one. And when the angle of emergence is double the angle of incidence, so this is wrong, and the incident ray and the emergent ray are symmetric to the prism. Okay, so these are the three options which are the correct one. So you can say A, B and C are correct. Next question. We are given the refractive index of a converging lens is 1.4. What will be the focal length of this lens if it is placed in a medium of a refractive index of the same refractive index, assuming that the radius of curvature of the facies of lens are R1 and R2 respectively. Okay, so it means lens is placed in a refractive index which is same refractive index, that is 1.4. And we have to find out the focal length. So we know the, you can say, basic formula, that our 1 upon focal length is equal to refractive index of lens divided by refractive index of medium minus 1, and we have this as 1 upon R1 minus 1 upon R2. Here mu L is the refractive index of lens, and our mu M is the refractive index of medium. And in the question it says the refractive index of the lens, that is 1.4, and the medium is same, that is both are 1.4. So we can write that refractive index of lens is equal to refractive index of medium is equal to 1.4. So we can say 1 upon F is equal to 1.4 divided by 1.4 minus 1, and 1 R1 minus 1 upon R2. And these two terms cancel out, so this comes 1 minus 1, this comes as 0. So we get that 1 upon F is equal to 0, giving us that the focal length is equal to infinity. So option number 2 is the correct one. Option 2 is correct. Next question. We are given a deviation of a 2 degree is produced in a yellow ray when a prism of crown and flint glass are achromatically combined, taking dispersive power of crown and flint glass as 0.02 and 0.03 respectively, and refractive index for yellow light for these glasses is 1.5 and 1.6 respectively. The refracting angle for the crown glass prism will be, okay, so we have to find out the refractive index of the refractive angles of the crown glass. And this question is basically about the deviation without dispersion. This is deviation without dispersion. So we can just draw an approximate figure for that. So we have two prisms, and so this is a suppose crown, and this is our flint, and the incoming ray is our white ray. So this is the incident part, and we can just draw and this will be our red, violet, red, violet, and again this will be a white. So this is a white light, and this is also incoming also is our white. And we are given for dispersive power given and the angle is given. Okay, the deviation of 2 degrees produced in the yellow ray, and their effective indexes are given. So let us call this as lens number 1, prism number 1, and this as prism number 2. So therefore we can write, we are given the dispersive power for the first lens prism, that is W1 is equal to 0.02. Its refractive index is also given to us, that is 1.5. And for the second lens we are also given dispersive power 0.3, and its refractive index is given as 1.6. And we are given that it is having a achromatic combined. So achromatic combined means that the theta net will be equal to 0. So we can say achromatic combination our theta net will be equal to 0, or we can say that theta because of first lens minus theta of the second lens will be equal to 0, or we can say theta 1 is equal to theta 2. And we know that our theta 1 is our omega 1 multiplied by first deviation, that is delta 1, and omega 2 multiplied by the second deviation, that is our delta 2. Okay. So from here we can say omega 1 delta 1 is equal to omega 2 delta 2, and the net deviation is also given to us, that is 2 degree. You can say net deviation that is our delta net, it is given as 2. So we can say our delta 1 minus delta 2 is equal to 2 degree. So we have two equations. This is our first equation and this is our second equation. So from equation 1 and 2, equation 1 and 2, we can write that our delta 1 minus we substitute delta 2 in terms of omega 1, omega 2 and delta 1. So we get this as omega 1 delta 1 divided by omega 2 is equal to 2 degree. And we take delta 1 as common. We already know our omega 1 and omega 2, and that is our omega 1 is our 0.02 and 0.03. 0.02 and 0.03, that is equal to 2. So from here we can find out that our delta 1 will be equal to 1 minus 2 upon 3 is equal to 2. This gives us that delta 1 is equal to 3 minus 2 is 1, so delta 1 comes as 6 degrees. And we already know the relationship between the deviation and the angle of the prism. So we know that our delta 1 is equal to mu 1 minus 1 and angle of the prism, that is of A1. And delta 1 is given to a 6 degree. We just calculated. This comes as 6. Mu 1 we know is our 1.5 minus 1, and this is A1. So this gives us A1 is equal to 12 degree. This was, we were able to find out. So this is our 12 degree. Next question. And it states that the image of an object placed in air formed by a convex refracting surface is at a distance of 10 meters behind the surface. The image is real and is at a 2/3 of the distance of the object from the surface. The wavelength of the light inside the surface is 2/3 times the wavelength in the air. The radius of curvature of the surface is, curved surface is x by 13 meter. The value of x is. So here everything is given in terms of the relative, you can say. Okay. So first of all, we are given that we have a convex refracting surface. So the convex refracting surface, and let us suppose this is the principal axis. We have object here, and correspondingly it says that the image is formed at a distance of 10 meter behind the surface. Okay. So let us suppose this is the position of the image, and this is given as 10 to us. Object distance, let us suppose, is given as u, and their refractive index here, so we have this as mu 1, let us suppose this is our mu 2. So obviously mu 1 is our air and mu 2 is our some surface, so this will be our air. So mu 2 will be equal to, okay, mu 2 we can calculate, because in terms of we have the you can say the wavelength are given to us. Okay, so we start from that our wavelength in the medium is equal to wavelength in the air or vacuum divided by the refractive index, and medium is, wavelength medium is 2/3, so this comes as 2/3, and the wavelength light inside surface 2/3. Okay, their product is given, so we can say that this is equal to 2/3 and times lambda of air is equal to lambda of air upon refractive index. Here air and air cancels out, so we get our refractive index mu will be equal to 3/2, and this is nothing but our mu 2. and we know the standard formula, and that states that our mu2 upon v minus mu1 upon u is equal to mu2 minus mu1 upon r. And we are given that our u is equal to 2/3 of the distance. Okay, so it means our v will be equal to 2/3 times u. V is our 10, so this comes as 10 is equal to 2/3 times u, giving us that our u, because this goes by 5, so u comes as 15. And for this it will be our negative sign, so therefore we substitute. We get our 3/2 divided by v, and v is our 10 minus 1, and u is our minus of 15, is equal to, this comes as 3/2 minus 1 and divided by r. So this comes as 3/20 plus 1/15. 3/20 plus 1/15 is equal to, and this is our 1/2r. So the LCM will be coming as 60, and 60 is 23, this comes 9, 9 plus 4 is 13. So this comes as 13 upon 60 is equal to 1/2r. Here 60 goes by 30, so we get that our r is equal to 30 upon 13. Okay. And in the question we are given that the curvature is x upon 13. So this is our x upon 13. This gives us the value of x will be equal to 30. So value of x is our 30. Next question, and it states that region 1 and region 2 are separated by a spherical surface of radius 25 centimeter. An object is kept in the region 1 at a distance of 40 centimeter from the surface. The distance of the image from the surface is. So this question is also based on directly the formula, and we have to find out the distance of the image. Okay, and we have the two regions, region 1 as well as region 2, and they have respective refractive indexes, that is 1.25 and 1.14. So object is in the region 1. Okay, so we can just sort it out and using the same formula, and that formula gives us that So here we are given the radius of curvature and distance of object. So we can use the formula, which is our mu2 upon v minus mu1 upon u is equal to mu2 minus mu1 upon r. And here u is distance of object is given as 40 centimeter. So our u is equal to minus of 40, and the radius of curvature, radius of curvature is given as 25, so that is our minus of 25, and we need to find out the value of v. So we substitute it. Mu2 is given to us 1.4, so this comes as 1.4 upon v minus 1.25 divided by minus of 40 is equal to we have mu2 minus mu1, so mu2 is our 1.4 minus 1.25, and this comes as minus of 25. So this comes as 1.4 upon v is equal to 1.4 minus 1.25. This will be our 0.15, so 0.15 minus and divided by 25. This is minus, and become this 1.25 divided by 40, and LCM will be equal to, we can say LCM will be equal to 25 into 40, and this comes as minus of 600, that is minus of 6, and minus of 125 multiplied by 25. So we can just write that our v will be coming equal to as minus 37.58 centimeters. So option number 4 is the correct one. 4 is correct one. Next question. It states that an object viewed from a near point distance of 25 centimeter using a microscopic lens with a magnification of 6 gives an unresolved image. A resolved image is observed at infinite distance with a total magnification double the earlier, using an eyepiece along with a given lens and a tube of length 0.6 meter. If the focal length of the eyepiece is equal to, so we have to find out the focal length of the eyepiece. And this is basically, you can say, divided into two parts. First one is our simple microscope, and other one is a compound microscope. So we start with a simple microscope. Simple microscope, and we know that its magnification is equal to 1 plus capital D divided by the focal length of the objective. Magnification is given as 6, capital D is given as 25. So we can write magnification is 6 is equal to 1 plus D is our 25, focal length of objective. This comes as 5 is equal to 25, and F naught, 25 goes by 5, and this gives us that our F naught is equal to 5 centimeters. Now in this some changes are made, and that you can say magnification becomes double, and there is a tube, and then there is a eyepiece also. Okay. So that becomes a compound microscope. can say for compound microscope, we have our magnification M is equal to length of the tube multiplied by capital D, and product is focal length of the object and focal length of the eyepiece. It says the magnification becomes double, so this comes as 6 multiplied by 2 is equal to length of the tube is given as 60, capital D is 25, of objective focal length is 5, and eyepiece over E. And this goes by 10, this goes by 5, 5 goes by 5, therefore we get a focal length of eyepiece is 25 centimeters. This comes as 25. Next question. It says that a ray of light passes from a denser medium to a rarer medium at an angle of incident I. The reflected and refracted rays make an angle of 90 degrees with each other. The angle of reflection and refraction are respectively R and R prime, then the critical angle is given by. So we are given that, let me redraw this basic figure here. So we have a normal, incidence angle is given as I, we have a reflected ray that is given as R, and we have a refracted ray and its angle is given as R prime. And the angle between reflected and refracted is 90 degree. This angle is about 90 degree. And let us call this point as point O, and here let us assume that this is N1 and this is our N2. Okay. And so if we use Snell's law at point O, Snell's law at point O, we get this as N1 sine of I is equal to our N2 sine of our R prime. And for our relationship between R prime and R, this is our normal. Normal is a straight line, so we can say for normal N, we can write our R plus 90 plus R prime is equal to 180 degree. So from here we can write that our R prime will be equal to, this comes as 90 minus R. And we also know that our incident angle is equal to reflected angle. So therefore we can write our R prime is equal to 90 minus I. So we can, let us call this as equation number 1. So we can say from equation 1, we can write this as our N1 sine of I is equal to our N2 sine of 90 minus I. And this gives us our N1 sine of I is equal to N2, and we have cos of I. which gives us that tangent of I is equal to n2 upon n1. And we have to find out the critical angle. Let us suppose the critical angle is C. Critical angle is our C. We can write that our sine of C will be equal to refractive index n2 divided by n1. n2 divided by n1 is our tangent of I. So from here we can say that our C is equal to sine inverse of tangent of I. Tangent I is equal to R, so we can say this is our sine inverse of tangent of R. So sine inverse of tangent of R, option number 4 is the correct one. Four is correct. Next question. Second. Okay. We are given a ray of laser of wavelength 630 nanometer is incident at an angle of 30 degree at a diamond air interface. It is going from diamond to air. The refractive index of the diamond is 2.42 and that of air is 1. Choose the correct option. So we are given that the angle of incidence and the ray is going from diamond to air. Okay, so we can just draw a figure. So we have a diamond and we have a air. Angle of incidence is given as (30°) and refractive index of the diamond, that is our mu1, is given as 2.42 and mu2 for air we know is our 1, and it will be refracted. Let us suppose this angle is given as R, and we call this a point as point O. So if we have Snell's law at point O, we can write this as V1 sine of I is equal to mu2 sine of R. And so here we have to find out what will be the angle of refraction in the first, second and third, or first, second and fourth, or in third says whether refraction is possible or not. So for refraction not possible, which means that total internal reflection should be taking place. Okay, so this is the meaning from here, that there should be total internal reflection, and for that we need to deal with the critical angle. And angle of incidence is our 30. So we simply find out the critical angle. And you can say for total internal reflection, we are given that our sine of C is equal to our, we have this as mu2 upon mu1. mu1 upon mu2, sorry, mu2 upon mu1. mu2 upon mu1. So this becomes 1 upon 2.42. So here C is our critical angle. Okay. And from C we can say is equal to sine inverse of 1 upon 2.42, and 2.42 is approximately equal to 0.41. So this comes as sine inverse of 0.41, and is it approximately equal to 24.4 degree. Now we can simply make a comparison between our angle of incidence and critical angle. We are given that angle of incidence is our 30 degree, which is greater than the critical angle, and the critical angle is our 24.4. So which basically tells us that total internal reflection takes place. Okay. So total internal reflection takes place, so there is no need to find out the angle of refraction. Okay. So refraction is not possible, so option number 3 is correct. You can say from here that refraction is not possible, therefore option 3 is correct. Next question. And it states that a prism of refractive index mu and angle of prism A is placed in the position of minimum angle of deviation. If the minimum angle of deviation is also A, then in terms of refractive index. Okay, so we have to find out the relationship between the, you can say, refractive index and the minimum deviation. So we already know the relationship that our mu, refractive index, is equal to sine inverse of A plus delta of m divided by 2, and this comes as sine of A by 2. And in this particular question, it states that our angle of minimum deviation is given as equal to A. So we substitute the value and we get that our mu will be equal to sine of A plus A divided by 2, and this comes as sine of A by 2, and this is equal to 2A. So we get here sine of A divided by sine of A divided by 2. So in the numerator we can use trigonometric identity with respect to the half angle. So we get this as 2 sine of A by 2 and cos A by 2 divided by sine A by 2. Sine A by 2, sine A by 2 cancels out. So we get a refractive index is equal to 2 cos A by 2. 2 cos A by 2. So therefore we can write that our angle of the prism, that is A, will be equal to 2 cos inverse mu by 2. So we get the 2 cos inverse mu by 2, that is option number 1 is the correct one. 1 is correct. Next question. It states that a ray of light entering from air into a denser medium of refractive index 4/3 as shown in the figure. The light ray suffers total internal reflection at the adjacent surface as shown. The maximum value of theta should be equal to. So we are given this figure. Here theta is the angle of incidence, and let us call this as point as A, this point as B. And at B, total internal reflections takes place. Okay. So we have to find out the maximum value of this angle theta. And this maximum value of angle theta is only possible when you can say the ray at this point B just grazes the wall. Okay, so it is going something like this. So we can just draw an approximate figure for that. And we have a ray of light. This is point B, and this is normal angle of theta. This is given as theta prime, and it should be just grazing the wall. And this is our normal angle. This is given as theta double prime. And refractive index is given as, let us suppose this is our mu2, that is 4/3, and here we have mu1, that is our air, that is our 1. Okay. So we can use the, so we can say for maximum value of theta, for maximum theta, ray at point B goes on just grazing the you can say, let me call this as P, Q and R. So just grazing the QR surface. Therefore, at point, you can say B, we can use Snell's law. Snell's law at B, we can write this as mu2 times sine of theta double prime will be equal to mu1, and this is a sine of 90. Okay. Mu1 is our 1 and sine 90 is also our 1, so we get here, and mu2 is our 4/3. So we can say our theta double prime will be equal to sine inverse of 3/4, and we have this as A. Let us call this point as O. So in triangle AOB, we have theta prime plus theta double prime plus 90 is equal to 180. Therefore, we can say that our theta prime is equal to pi/2 minus theta double prime. and we need to find out the value of theta. Okay, now we can use the Snell's law at point A. Snell's law at point A, we can say our mu1, here it is mu1 sine of theta is equal to our mu2 sine of theta prime, and mu1 is our 1, so this comes as 1 multiplied by sine of theta. Mu2 is our 4 by 3, and this comes as sine of theta prime, we know, is our pi by 2 minus theta double prime, so this comes as pi by 2 minus theta double prime, and theta, okay, this comes as 4 by 3 cos of theta double prime, and theta double prime is sine inverse 3 by 4. Therefore we get that our sine of theta is equal to 4 by 3, and we have this cos of theta double prime is one second. Okay, we can just use it as a value also. Let me write in the form of the value. So we can just draw a triangle, and our theta double prime is our sine of theta prime is 3 by 4. So this is our theta double prime, so this we have 3 and this we have 4, so this will be our square root of 7, and we get this as cos of double prime. Now what is the sine cos of double prime? Cos of double prime is our sine double prime. Okay, and something, let me check one second. This is 4 by 3 cos of theta prime. Okay, yeah, so we can write that our sine of theta, this will be our 4 by 3, and we have this is cos of, and we can write this as cos of, cos inverse, sorry, rather square root of 7 divided by 4, and we can write this will be equal to sine of theta is equal to 4 by 3 multiplied by square root of 7 divided by 4, and 4 and 4 goes away, so this gives us that theta is equal to sine inverse of square root of 7 divided by 3. So we get this as square root of 7 divided by 3. Square root of 7 divided by 3. Option number 1 is the correct one. One is correct. Okay, there is another question for which I forgot to upload the snapshot of the question, and that question was based on the, you can say, we are given a prism, and like this we are given a prism, and light is incident. Let us suppose this prism is a P, Q and R, and we are given that the light is incident on this surface at an angle of 45. This is about 90 degree. So we have to find out, there are three you can say rays of light are being used. Okay, so one is a red, another one is a green, and finally is our blue. So we have to find out which of these ray of light will be going to pass through this PR. So basically this is with respect to the critical angle, and we have to find out the critical angle for the red, green and blue and try to sort it out from there. And angle of incidence is our 45 degree. So you can say that each because this will be also 45 isosceles prism, so this will be also 45, so the angle of incidence will be at a 45 degree. So we can say each incident ray make angle of 45 with the normal on the face PR, with normal on face PR, and for the wavelength to pass through the face PR, the angle should be equal to, you can say, with respect to critical angle, we have to make a comparison for that. So it means we can say the wavelength corresponding to the incident angle is less than critical angle. Critical angle will pass through PR. Will pass through PR. So if our critical angle is C, critical angle is our C, so you can say our sine of C is equal to 1 upon refractive index of the prism, or we can say our C is equal to sine inverse of 1 upon mu. And for the ray to pass, so you can say if our critical angle C is greater than equal to 45 degree, then that ray will pass face PR. So let us start with our red. So you can say for red, critical angle red will be equal to our sine inverse refractive index is given to that is 1.27. So in the question itself we are given that refractive index of red is our 1.27. Refractive index for green is also given to us as 1.42, and refractive index for blue, it is also given to us as 1.49. So we get our C for red will be approximately equal to 51.94. So it means the critical angle for red is greater than our incident angle 45 degree. Therefore we can say red will pass. Similarly, we do it for green. We have C for green. That is our sine inverse of 1.142, approximately 44.76, and so we can say our critical angle is less than our 45. So it means green will not pass. Not pass. And finally we have for blue, that is our sine inverse 1 upon 1.49, approximately, which comes as 42.15. Therefore this C is less than 45, C of green, sorry, C of blue. And this was C for green. Therefore green, not green, but blue will not pass. Blue will not pass. Okay. So only red will pass through PR. Only red will pass through PR. So this completes all the questions of part 2 for the year 2021. So in the part 3 we are going to solve the remaining question for the mains, and that will be also including the advanced question which were asked in the year 2021. This completes the part 2. Thank you.